Hello, in this video, we will begin to introduce recursion in chapter 17. Recursion is a technique that leads to elegant solutions to problems that are inherently recursive. Let's look at this H-shape problem. So look, this is an H-shape of order 0. This is H-shape. Now this is order 1, and this is order 2, and this is order 3, and this is order 4. This is a fractal problem. To write a program to display this H-shape, you will need to use recursion. Recursion will make this program easy to write and gives you an elegant solution. So we're going to introduce recursion in this chapter. To begin, we're going to use a simple problem just to demonstrate how recursion works, how to write a recursive method function. So this is not necessarily an efficient solution, and just want to demonstrate and how recursion works. Recursion is a function that invokes itself. So this is recursive function. Recursion is on the function level. So now let's look at this factorial problem. So here's the factorial problem is for positive integers. So for the 0 too, okay? So including 0, so 0 or positive integers. For 0, factorial of 0 is 1. And factorial n is defined recursively as n times n minus 1's factorial. So this is in mathematics recursive definition. This can be coded naturally using recursion as follows. So we are going to write it this way here. We compute the factorial of n. So we simply test if n is 0, that's over, return 1. Else, we're going to return n times factorial n minus 1. So this is a recursion. It's the function factorial now calls itself, but using different arguments. So let's look at this, put all this together in this test program. And this is the main prompt user to enter integer n, and now invoke factorial n. So this is factorial n. If n is 0, returns 1, else returns n times factorial n minus 1. In a recursive function, you always have one or more best case. That is a stopping condition. Once this case is true, and the recursion stops. So here, this is called function itself. It's called reduction to the same problem with a different size. Now this is n, now it's reduced to n minus 1, but you're calling the same function factorial. Let's see how it works behind the scene. So let's use this animation, see how it is done behind the scene for computing factorial 3. So every time a function is called, an activation frame is created and put on the top of the stack. So this is now begin with factorial 4. So this is right here, factorial 4 is here. And now 4 times factorial 3, so factorial 3 is now here. And now factorial 2 and factorial 1 and factorial 0 here. Okay, now when executing factorial 0, so now you're going to see this is going to return 1 now. So now it's finished. And next is on the top of the stack is this. It returns. So factorial 0 returns 1. So now 1 times 1. And now is 2 times factorial 1 is 2 times 1. And now 2 times factorial, 3 times factorial 2. So this 3 times 2. So this is 6. And now 4 times factorial 3 is 6. 4 times 6. So this is now returns 24. This is behind the scene how it works. Now, when you write it at the high level, it's much simpler. So look, just writing it literally, it's like you translating mathematic recursive definition into the function factorial. That is all for the introduction to recursive functions. We're going to use more examples to demonstrate recursion. See you on the next video.